So welcome back. We're going to be doing 5.7, number 2, the actual lesson. And I'm going to give you an alternative way how to graph this without using a calculator. So in the event that on the test, I tell you, you have to describe how you'd graph this, because normally I would just have you guys graph this on a graphing calculator. But there's a couple cases where you're not going to have access to a graphing calculator and they're expecting you to know how to graph it by hand. So the first thing that I'm going to do is when I look at this system, they gave it to me in what's called standard form, which whenever they give it to me in standard form, I just use whatever they give me. So if they give it to me in standard form, then I'm gonna find intercepts. If they give it to me in y equals mx plus b form, slope intercept form, then I'm gonna graph it like right off. So the first thing that I'm gonna show you is how to graph using intercepts. So when I graph using intercepts, the first one I'm gonna do is I'm gonna graph the bottom one. Is I say, well, if x equals to 0, what's y, right? So this part, right, the 6x plus 9y greater than 30, I'm really just thinking about it as equal to 30, okay? So I'm really just thinking about this as equal, just because when I'm graphing something, I need to find that border, and then I can figure out which side I'm going to graph. So if this is 0, right? So I get 9y equals to 30. And I get y is equal to, what is that? 3 1/3. And you're like, ew, Miss Johnson, that's a gross number. But that's okay. I don't need it to be pretty. They're asking me to sketch. And then here I'm gonna do the same thing. So this is one of my intercepts. It's at 0, 3 1/3. Right? Then I'm going to go in here and graph and do the same thing, except for now I'm going to pretend that y is 0. So if y is 0, what's x? That's what I want to know. So you can imagine me going 6x plus 9y equals to 30 and pretending that y is 0. So that whole thing goes away. So I get 6x equals to 30. Therefore, x equals to 5. And my point is 5, 0. So these are two significant points on my border of my inequality that I'm going to graph. So I don't know how I'm supposed to graph this right now. So I'm hoping that it'll fit on this, the way I've set up my quadrants. And this is just a sketch, so it's okay if it's not perfect. So I go to 5, 0, which is 1, 2, 3, 4, 5, and I make a dot. And I go to 0, 3 1/3, which I know you guys don't like graphing fractions, but it's just in between 3 and 4, closer to 3. Okay. So there's my two dots. If you can imagine that I'm going to draw a line through there, right? I'm going to draw a line through there. And is this line dashed or solid? Is this line dashed or solid? Well, this one's dashed, which basically means everybody on that line, that dashed line, is not a solution for that inequality, right? Because, like, for example, if I plug in 5, 0 to here, I get 6 times 5 is 30, plus this is 0. So 30. Is 30 greater than 30? And you're like, no, it's equal to it. So it's not. So that would be a false statement. So 5, 0 is not a solution on that. Okay. So I'm going to draw a dotted line. And because we're just sketching here, I'm just going to like do my best to make it straight. I didn't use a ruler. If I told you to graph it with precision, then I probably would see this 3 1/3, and then I'd probably scale my axes differently. But because this is just a sketch, this is where I'm going to go with it. Okay, then it says, now I have to figure out if I shade down here or up here. And you should know that you're shading because of this greater than symbol. If I was just graphing 6x plus 9y equals to 30, I draw this solid line and I'm done, right? But because it's greater than, I'm looking for all the points that make this true. So the easiest way to do this is by plugging in my favorite point. My favoriteest point is 0, 0. So I go 0 plus 0. Is that greater than 30? And the answer is no. So I'm going to make a little like, nope, it's not a solution. So where should I shade? if I can't shade below the line, where should I shade? And you're like, oh, I should shade above the line. And you're right. So I'm going to shade all of this stuff. So I'll make this guy pink. So I'm going to kind of try to make him as solid as possible so that when I come in and shade again, everybody knows that it goes up to that line. So I think I did a pretty good coloring job. I think I missed some spots. But the whole point is that it's that part. Okay, so I'm going to highlight that guy in pink so we're all good. Now, I'm going to do the same exact thing with this one. But first, I want you to try. So go ahead and pause the video and come back to me when you are ready. Okay, pause the video and come back to me when you're ready. And let's see if you can do the same work. Okay, so we're going to do the other equation, which I'm going to do, shoot, where am I going to do this? I'll do it all on this side. So it says negative 10x plus 6y is less than or equal to 90. And the first one we're going to do is if x is equal to 0, what's our y? And the next one we're going to do if x equals to, I don't know, what's our y? I mean, if y equals to 0, what's our x? So I'm just going to plug in. So this would say negative 10x plus 6y is equal to 90. And again, I'm using equal to because I'm just looking for the point. So x is 0, so that says 6y equals to 90. So therefore y equals to 15. And our point is 0, 15, which is all the way up there, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Great. I didn't leave enough room. So let's see. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm just going to pretend it's right there. It doesn't have to be perfect right now. I should have just included it, but I didn't. Not a big deal. Okay, so the next one I'm going to do, same thing. I'm going to do negative 10x plus 6y equals to 90. And then this time I'm going to pretend that y is 0. So I get negative 10x equals to 90. So x equals to negative 9. So my point is negative 9 comma 0. So when I graph that, I'm on the wrong side of this graph, but that's okay. So I'm going to go to negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to pretend it's right here. Oh, I should be using blue, right? So this one is going to be a solid line, right? Because of this equal to makes it solid, right? The equal to makes it solid, meaning everybody on that is a solution. And again, I'm going to try to make this like that, right? So can you imagine that this pink shaded is all like this and it's all like this, right? Okay. Then I have to figure out which side to shade, which again, my favorite way to shade is if I pick this 0, 0 and see if it works. So 0 plus 0, is that less than 90? And you're like, yes, right? Oops, sorry for the blue guy. It's yes. So that means all down here underneath the line is all shaded. So sorry, this comes out green. On my iPad, it's more bluish, but where is the solution? It's going to be all this section here that's shaded. Now, on the test, on the quiz, on the last quiz, you all said, not all of you, but a bunch of you said this point right here is the solution, and that's not true. It's all of this section here, which is our solution. So this is our solution set. Solution set. So that means every point shaded pink and green are solutions. Okay, so even outside this graph, it's all these here. Now this guy's not a solution because he's only pink. This guy's not a solution because he's only green. This guy right here is not a solution because this is a dashed line and this is a solid. But everybody along this line is a solution set, if that makes sense. All right, thanks for listening. Have a great day.